Hi, ladies and gentlemen. My name is Kevin from Cowrie Heat Treatment, and it is my pleasure to conduct this presentation about Cowrie's brazed plate heat exchanger and how Cowrie's brazed plate heat exchanger can be utilized in a natural refrigerant world. Today, I will go through 5 topics with you. The first topic is the solution that Cowrie offers in commercial refrigeration, especially in convenience store, supermarket, and hypermarket. Second topic is about how microchannel and asymmetric design can improve the performance. The third topic is the reliability and efficiency improvements for heat pump and chillers. The fourth topic is the product characteristics of Cowrie's CO2 brazed plate heat exchangers. And the last topic is the truth of Cowrie's double wall brazed plate heat exchanger. Let's move into the first topic. So the most common natural refrigerant in the commercial refrigeration are propane and CO2. And let's talk about how Cowrie's brazed plate heat exchanger can be utilized on both natural refrigerants. Cowrie offers total solution for commercial refrigeration, as convenience stores and supermarkets are in every corner of our lives. Imagine if we replace all refrigerants by natural refrigerants. This will make a huge difference in our environment. Because the propane is a very flammable gas, its usage amount must be limited. And this is where the microchannel comes in. By using microchannel, we are able to reduce the amount of refrigeration charge and save the weight of brazed plate heat exchanger. Another choice is the CO2 system, which only has global warming potential of 1. However, its high working pressure is hard for the system components. But here, Cowrie offers brazed plate heat exchangers with maximum working pressure up to 140 bars. This makes the CO2 system easier to handle. In this topic, let's look at how microchannel and asymmetric design can improve the performance. In Cowrie, we offer customers with more options. If we look on the right side of the slide, it shows a few different cross-sections of the brazed plate heat exchangers. The first pattern is the standard or conventional pattern. As you can see, both sides having the same volume. And the second pattern shows how microchannel is. Both sides are significantly smaller than the standard pattern. So this saves the refrigerant charge by 20%. And the third pattern is so-called asymmetric pattern. And it allows one side to be smaller than the other. So it keeps the benefit of microchannel with less refrigerant charge while keeping the water side with bigger volume, so the pressure drop can be limited. The asymmetric is still under development, but we will have an announcement for its release very soon. Please stay tuned for the updates. And last but not the least, all patterns can be constructed in a robust way, so they can handle up to 140 bars for CO2 applications. And in this slide, here is an example of a low global warming potential water loop display unit. By adapting a microchannel condenser, we are able to save 20% of the refrigerant charge. This is perfectly suitable for smaller scale showcase with R290 propane. In this topic, let's look at an example of the reliability and efficiency improvements for heat pump and chillers. This is an example of an air chiller or heat pump. The evaporator, economizer, and heat recovery unit require brazed plate heat exchangers. If we replace these 3 brazed plate heat exchangers with microchannels, they can be reduced in size and weight by 27% compared with standard conventional brazed plate heat exchangers. and also save 21% in carbon footprint during the manufacturing process. And in this topic, let's look at brazed plate heat exchanger in CO2 applications. The characteristics of CO2 is its high working pressure, and we need to have a strong and robust unit to cope with this pressure requirement. First of all, Cowrie is not new in CO2 application. The C series for CO2 was launched back in 2008, and it received many patents in major regions of the world. And they are constructed in a robust and muscular way, so the burst pressure is over 650 bar. And we also run cycling tests from 0 to 140 bars with over 100,000 cycles. One of the main advantages of Cowrie's CO2 brazed plate heat exchanger is its frame-free design. So there is no extra reinforcement frame around the heat exchanger. It also offers wide range of capacities from 0.3 to 150 kilowatts, and it can be made with 140 bar on both sides, making it a good choice for CO2 transcritical system. As for commercial and industrial applications, it can be used in gas cooler, suction line heat exchanger, and evaporative condenser. Here is an example of a CO2 rack and booster. Because of its frame-free design, we can achieve a weight reduction from 15 to 30%. Also, with its unique chevron plate design, the pressure drop can also be improved by 14 to 34%. With all these benefits, it saves power, space, and most importantly, the cost. And here, we have a multiple circuit CO2 unit. This is one of Cowrie's patented design to integrate 3 circuits into one unit, with all circuits capable of handling up to 140 bars. It is specially designed for CO2 cascade system, and let's see how it works. Here we have a CO2 cascade and multi-driven force heat pump. There are 3 main components which require brazed plate heat exchangers: the condenser, the cascade heat exchanger, and gas cooler. Instead of having 3 separate brazed plate heat exchangers, we can just use one single multiple circuits unit, and making the system a whole lot simpler, lighter, and cheaper. In this topic, I would like to talk about the truth of Cowrie's double wall technology. In the double wall application, we want to make sure that fluids from both sides will never mix due to an internal leakage or heat exchanger failure. So in Cowrie's concept, we want to focus on proactive prevention. If we look at the diagram on the right, there is a simple comparison between a single wall and a double wall scenario. An internal leakage takes place in a single wall brazed plate heat exchanger. Both sides will mix immediately, and we end up with a system failure. So imagine if the fluid is a hot water application which contacts human skin. The system failure can be a disaster. Therefore, Cowrie developed a double wall technology. Not only the second layer prevents the fluids to mix in case of the first layer breaks, but there's also a visible leak from outside of the heat exchanger, allowing the end user to replace a new unit. The picture below shows a failure in the first layer. The fluid actually leaks from the side of the heat exchanger, but inside still remains intact and internal leakage does not happen. So how did Cowrie achieve this? Let's take a look on the cross-section of the double wall brazed plate heat exchanger and make a quick comparison between Cowrie's double wall and others available in the market. In Cowrie's double wall, each plate has sufficient clearance in between, so the leakage will be 100% visible from outside. With the others available in the market, there is not much clearance between the plates, so the leakage is not always visible from outside. And in Cowry, we believe a double wall system should allow the user to detect any possible leak and replace a new unit. This is the meaning of the proactive prevention. And very importantly, if the leak cannot be picked up 100%, the double wall system is just to prolong the life of heat exchanger and serve not much protection to the end user. Cowry's double wall system wants to make sure the end user is totally protected in their daily usage. This concludes my presentation. If you have any questions, please feel free to write to sales@cowry.com.tw. Our experts will be more than happy to answer your questions. Thank you very much. I will see you next time.